Hi, my name is Shravani, and my research topic is analysis on peer-to-peer network security and poisoning the network. I'm going to talk about the introduction, relevance, motivation, applications, analysis, future scope, overall assessment, conclusion, followed by the references. So first, let me talk about peer-to-peer networks. Peer is a more simplified network because it does not require network operating system or any expensive server to access the files. Instead, they can have separate workstations to complete this job. So each user in a peer-to-peer network can share files to other peers without disturbing other systems. Peer-to-peer networks are vulnerable. Some of the file sharing applications include Freenet, Napster, Direct Connect, Nutella, and eDonkey. Peer-to-peer network uses direct exchange of sharing computer resources among the peers. There's no centralization because everything is self-organized and there's distributed control over the whole network. When peer-to-peer network model is compared with client server model, that is completely different because in peer-to-peer network, peer access both client and also the server. Even though peer-to-peer networks do not have central coordination by servers or stable hosts, they share resources like network bandwidth and disk capacity. Peer-to-peer applications are divided based on their usage. Decentralized peers will spread services among the users. So there are some possible attacks. The first type of attack is attacks on peer-to-peer networks, and this attack has two types in it. The first type of attack is listening query, and the second type of attack are leechers. So first let me talk about listening queries. Every node can see critical measures of corresponding occurrences in its subgraph. There is no evidence that there is inconvenience caused by a node, which may listen the measures of queries and then respond back accordingly. The second type of attack is leechers. These network clients don't use administration for document sharing and will download the information. These clients will not involve in system information access, so they are not included into system. The second type of attack is attacks realized through peer-to-peer networks, and this has three types of attack in it. The first type of attack is distributed denial of service. The second type of attack is malware, and the third type of attack is poisoning the network. So first let me talk about the distributed denial of service attack. This attack makes a hub or system as its assets unaccessible to the proposed clients, and this will be done by overburdening the system. This type of attack gathers network nodes and then dispatches distributed denial of service attack against the same victim. Attackers will then utilize questioning idea of peer-to-peer system to overburden the system, and this will disturb the system. And there will be additional traffic which will be injected to the system. The second type is the malware. The number of portrait attacks can be joined with the malware, like content verification with assault utilizing malware. TDL4 utilizes this one. Because this is different to expel from personal computer, because it taints master boot record, that is MBR. This is uncommon segment which has code executed before the actual framework begins. And the third type is poisoning the network, which means infusing pointless information into the framework. Like fake things may be added to a file which yields invalid inquiry results. Poisoning can be used as fodder for DDoS attacks. This can be done in two ways. The first one is index poisoning, and the second one is root table poisoning. In index poisoning, fake records are embedded into the list indicating objective IP and port number. So when the peer looks for a resource, it may get fake area data from harmed files either from central directory or other peer. So when peer is looking up for a resource, it may get resource from a fake area, and that data may affect the peer and also its neighboring peers even. And the requesting peer makes an association with the objective. This may lead to the TCP association, and a distributed denial of service attack can happen. The second type is root table poisoning. In this type, attacker uses the same sort of directing condition of the present pair. Firstly, the direction of the present pairs will be noted down, and then same sort of direction will be created by the attacker so that it can be unidentified. The attacker will look into the neighboring peer's routing table and makes a report message indicating the target. So this report message first contains the information about the neighboring peer, and then about the neighboring peer's routing table, and then about the target. Then this target will get a connection request and will dismiss them accordingly. Generally, peer-to-peer networks have an instrument to expel peers from routing table and refresh them constantly. So, in this way, objectives are expelled from routing tables of the associate pairs. So, the third type of attack is attacks on users of peer-to-peer network. And in this, we have two types. The first type is content verification, and the second type is stealing identity or data. So, first, let me talk about the content verification. Content verification is nothing but a validity check. So the valid check of the downloaded document, if a record is being downloaded, it should confirm that document relates to that particular record and excludes the undesirable part like malware. So if a document is being downloaded from an unknown source, it should first confirm that it actually relates to the record that was supposed to be downloaded, and it should not contain any malware. So for example, if a document is being downloaded from an unknown website, there may be some sort of malware that can be attached to a document, and that can be downloaded unknowingly by the user, which may affect that pair and also the neighboring pairs even. And the second type is stealing identity or data. So in this personal records of peer-to-peer users may be attacked by the advanced users, and they may abuse requests of these beginning users for assistance to get their information. So they may use the questioning idea in the peer-to-peer system. Like they may ask the beginning users, like, give us your information and we will help you. We will assist you through this entire network, and they may get the information of the user, and this will lead to the sharing of the entire framework details. So, according to my research, to poison a network, the primary goal is to launch a distributed denial of service attack on some victim to have traffic cross the ISP network without actually detecting them. So, the DDoS attack will be launched so that the additional traffic will be created, and that traffic will cross the ISP without being actually detected. So the distributed denial of service attack will traverse from an ingress pop of ISP to the ingress pop of ISP. So the attacker, before actually attacks the network, he will first poison the detector for some period of time by injecting the additional traffic. And this can be done in two types. The first type is random decoy injection, and the second type is replicated decoy injection. So before the attack is being done, actually the detector will get poisoned, and for this distributed denial of service attack will be used, like injecting the additional traffic, and that is of two types. So first, about random decoy injection. Random traffic will be created by using random generators, or the second type to create the additional traffic is replicated decoy injection, which means that a replicated traffic will be created and will be injected to the network. So to defend this, Mr. Kai Song and Kai Kwang proposed a defense protocol called RIEP Defense Protocol, and this also enforces the peer accountability. They developed analytical models to estimate growth of infected peers with index poisoning attacks using RIEP Defense Protocol. Each file index can be tracked back to publishing host without user authentication, but malicious peer can launch attack against itself for those IP addresses that are being authorized. So this defense protocol reduced traffic towards victim but could not restrict it. So I thought that keys should be allocated, and this information regarding the key should be stored in ISP, because only authorized persons can pass through the ISP, and this can reduce poisoning the network attack to some extent. And Mr. Kai Kwang and Zia Singh's research proved that their RIEB defense protocol enables peers cannot launch index poisoning attacks on unauthorized IP addresses, and thus also identifies peers which are attempting to launch the attack. So by using this RIEP defense protocol, it not only launches index poisoning attacks, but it also identifies who are about to attempt to launch this attack. So I want to conclude this, and in this one, the details of the peer-to-peer framework are being discussed, and how it works and what are its operations are being discussed, and the possible type of attacks in the network are being discussed. So attacks are categorized into three types, namely attacks on peer-to-peer networks, attacks realized through peer-to-peer networks, and attacks on users of peer-to-peer networks. So this gives a way to implement the solutions in the real-time peer-to-peer network, to analyze the validity of the solutions proposed in the future. Accumulation of research result will pave way for new questions related to the privacy of peer-to-peer network users, and this area of research has given new ideas regarding peer-to-peer security, which will devote in the future work. And these are the set of references which I used. Thank you.